All right. Welcome, everybody. February 24th, another edition of Fluence Community Call. And we got a pretty packed agenda today. There's some great news about Fluence. I think Evgeny has to share. We have Dmitry with some updates and some pretty exciting demo. And we have a hacker who's going to present his project. So to kick it off, Evgeny, maybe, what's new with Fluence?
Yeah, hello, hey everyone. I guess the biggest update since last call is that we officially announced our fundraise, $9 million round led by Multicoin Capital with participation of others, great funds and individuals. So we are really proud announcing it, really proud having this funding secured. Yeah, so this is exciting. We are published, like basically the goal of this fundraiser is to accelerate the building and ecosystem development. So we are published a lot of open positions, engineering roles, product marketing, developer evangelism roles, engineer management. So really trying to scale the team right now. And we are, with this round, we are getting closer to launching Fluence DAO. So this will be the next big step for our community. So currently it's just Fluence Labs who developing software. We will be creating DAO, and basically the DAO will be managing the network, and Fluence Labs will be participating in this alongside with the other community members, investors and partners and everyone else. So working on right now on preparation to the DAO launch, but on the development side also, we continue doing hackathons, bounties, and happy to be at this stage right now. And the other important thing is we've been in Denver last week. So Denver was pretty cool. A lot of people, 15,000 people there at the hackathon. Well, most of them actually was not for the hackathon. Most of them were just meeting each other. So it was pretty nice, great time. Met a lot of people, but the offline ETH Denver hackathon I think already ended on Sunday. But the online ETH Denver part is still alive, and I don't remember which exact deadline. Maybe Bernard can help me with dates. So there are still bounties published by us for this hackathon. They're still live and still opportunity to participate in that. Yeah, I think that's it. That's updates on my side.
Yeah, with respect to the virtual side of the hackathon, it goes until I think the end of March 24th or something like that. If you look at the repo, GitHub/Fluence, you see Fluence Labs, you see the repo for ETH Denver with all the bounties. I think we have 3 bounties. There's I think up to $15,000 still available, and it's actually some pretty cool pushing. I don't have them in front of me. I have to look them up. But they're pretty good, and if any one of you is interested, hit us up in Discord, Telegram, whatever. We're happy to help you guys with the rest of the virtual hackathon, which we expect to be actually pretty sizable. Having said that, the in-person I think had over 100 teams, 200 teams, and I don't know how many submissions. It was crazy, so we expect nothing less for the virtual one. Dmitry, I think, has some updates on the tech side.
Should we just quickly also mention this Codeless hackathon? which is
I was
another
okay.
one.
Yeah. Okay. So I was okay. I was gonna have me to do the update and then Anna do an update, but sure. Anna, why don't you tell us about the upcoming hackathons?
Sure. So one hackathon, which the name is Codeless, conduct, is the hackathon for those who are non-techies, those of you guys who are super creative and good in design or writing articles or making videos or NFTs. So we have our bounties are like the pool, the prize pool is about 10,500. And several bounties have multiple winners. So this hackathon is already started. You can apply through Gitcoin and participate not only in our bounties, there are also common track and a lot of interesting stuff. That's for Codeless Hackathon. And then one other hackathon we will be starting, it's on 1st of March. It's the hackathon called We Are Millions, together with Swarm. So the bounties will be announced soon, and we will also notify everyone in Discord. That are the two hackathons that we will be running besides Denver one.
Okay. So lots of hacking going on, both the techs and non-techs. If you're interested or anybody you know interested, all the bounty listings and judging and submission instructions are going to be on GitHub, easy to find, /Fluence Labs. You'll find it there. All right, Dmitry, on to you.
So hi guys. I have some updates, and I have a talk, and ideally there should be something in between the updates and the talk. So first of all, we have a lot of things done last 2 weeks and delivered today or yesterday, like just recently. And the best way to learn what exactly was delivered is to subscribe to our updates channel on Telegram. Hopefully we will be cross-posting it to Discord as well, but currently everything is on the Telegram updates channel. But what I really want to mention is the first milestone of Marine Web. It's our effort to run WebAssembly interface types compatible WebAssembly services in JavaScript environment. So the first milestone is something in between the proof of concept that interface types really work inside the web browser and in the JavaScript environment, but it's like slightly more because it's actually currently used in production in the Fluence JavaScript peer implementation. So currently you cannot use Marine Web yet, and the only module that actually works with Marine Web is Aqua Virtual Machine. But if you download and use Fluence.js 0.20 and any later version, then Marine Web is under the hood. In the following weeks, we're going to reach the second milestone, which is simply providing a public API for the developers to run WebAssembly modules with interface types in the browser and on the JavaScript Fluence peer implementation. And the third milestone will be supporting multi-module services. So we will implement linking for our Marine Web services for JavaScript, just like just as linking works for WebAssembly services on the Rust node implementation. What does it mean for the developers? It means that if you want to use some complex logic, you can you can use it despite the environment. You can choose to use JavaScript or Rust or some another environment that is compatible with Node.js or with Rust, and you can just use it. If you develop a module, then it can be used in any environment. It makes the network more isomorphic, and in the following weeks and months, it will be heavily used by the Fluence protocol. So this is a very big update that we have. We also have some minor updates with Aqua CLI to simplify the life of developers. Now you can deploy schedule scripts with Aqua CLI, and this functionality is much more rich and useful than it was in the previous FLDist. So take a look on that. And finally, we delivered, released the Fluence Registry that I will have a talk about soon. So I'm done with the updates overview. If anyone wants to ask anything or add anything, maybe Mike, Valery, Pavel, Alexei, maybe anyone. No questions, no reactions.
No questions. No questions from anybody. Okay, quiet crowd today. Okay, Anna just informed me that the hacker or the team, the participant in the previous hackathon who was going to present today is not presenting. So Dmitry, we don't have a buffer for you. It's going straight into your presentation.
Okay, so I will share the presentation. Can you see it? Yeah.
Yeah, sure.
Fine tuning. Okay, so today I want to present the Fluence Registry, the default routing level of the Fluence network. So what's going to happen? First, I will show what Fluence Registry is just in 2 slides with the code snippet, just to show what it looks like if you want to have a fast line. Then I will discuss the design and the reason why registry designed this way, why it's implemented this way and not another way. And finally, hopefully, we'll have a demo. So first, I want just to remind what Fluence looks like. We have this picture, a wonderful picture that we have some Aqua script that flows from one client from the web browser, which is not publicly accessible, but it is Fluence peer, to some node, to another node, to another node, and on some node it could run different services and get data back from these services, and then it could reach some other peer, like another browser, or it can pin back to the caller. So it's pretty nice. It all happens without central coordination. You can describe protocols as Aqua scripts, and then compose them, compose the services, APIs, protocols, applications using Aqua, and everything should magically work. But when it comes to reality, the first question that is raised is how exactly to choose where these arrows should go, like how to understand to what node the script should flow, how to be sure that, for example, the client, despite the relay node is connected to, is reachable and can get a notification. So how exactly to make this topology is the problem of routing. And Fluence Registry is a solution, the default solution, not the only possible, but the default. And this is what it looks like. To use registry, you need to have something on the host language, for example, on the JavaScript side, and you need to have something in Aqua, as registry is a kind of protocol, and to compose protocols, you need to use Aqua. So on the left, we have creation of the Fluence peer to have the key pair, to have the public and private key to secure the root. Then you can create the root and to have the root ID. And finally, if anyone registers itself to this root, you can send a message to everyone who subscribed. And here we have some Aqua code. So we have that data type, a custom data type for event. We have some service that's going to be launched on the remote peer. And we want to deliver this event to all the registered peers of some root ID. So we resolve the root, its library function. And then for all the records for this root, for every peer registered, we can have a relay, we can have a peer ID, we can understand what exact service we want to call, and finally we can call the service and hence deliver the message. So this is what the developer experience looks like. And now I want to go deeper into the details and the motivation, why it's designed this way. So it's about the design approach. So what does it mean to have a routing in a decentralized network? So essentially, we want to run some computations on a particular peer. Given that the network consists of peers, including not publicly accessible peers, client peers, and these peers are different. They have different resources. They have some deployed services, which we expect them to run, or they could have an access to some data or to some capabilities, or they could participate or not participate in your application. So they are different. And on runtime, during the request, we need to find a peer to access its resources. So that's the problem that we want to solve. And we are going to solve this problem in the context of existing algorithms. And the main one is Kademlia. Kademlia is a backbone for many decentralized networks, including the Fluence network. And it's super nice, super efficient. It provides logarithmic complexity on the size of the network to make almost all the requests, which is pretty nice. But fundamentally, in the level of types, you can think of Kademlia as just two functions. First function is lookup. For any peer ID, you can get an address if this peer is online, known, and reachable. So for any peer in the network, you can do this. But if this peer is not reachable, if it's a client peer, or if it's offline, then you will not get the address to connect to. That's why the question mark. The second function is called Kademlia neighborhood. So for any hash, any nonce, any byte array, you can find a set of peer IDs or a set of peers called the neighborhood of this hash. And this neighborhood is consistent, but not predefined. It's not consistent in the meaning that you know what exactly you'll get for this hash. It's consistent, meaning that probably for every peer on the network, this neighborhood at the same time will be similar or the same. So that's why you can use this neighborhood for eventually consistent communication. But you cannot decide what peer will go to what to which neighborhood. And that's why Kademlia is not a solution, is not a complete solution for the routing problem. What do we want to have? Let's imagine that we have some root ID, and essentially what we want to have is some function that gets from this root ID to the registered set of peer IDs, to the predefined set, so that we can get the same peer IDs for the root ID if they are available. Then we want to have connectivity to that peer. So even if the target peer is not publicly accessible, if there is no public API, if it's a web browser, or if it's the node with public API, we want to be able to connect it in both cases somehow. The third problem is that we need to solve the last mile problem, which means that we need to have some routing logic inside the peer. We need to get the service ID that will serve our request inside the peer. So this is also what we want to have. And also there's a question about security. How can we protect this root ID from unauthorized writes? Should we do it at all? Should we do it in all cases? How exactly we want to protect it? What security level is enough or not? So it's a question. And finally, I'm speaking about root ID, but the question is how to get this root ID and what exact meaning it has. So that's kind of an application-specific logic, but it needs to be solved somehow. To find out how to solve it, let's take a look on the life cycle of routing. What happens on the way? So first of all, we have some criteria, application-specific criteria probably, and we need to decide what route to find. We need to have this root ID to look it up later. Then we have a distributed part. We need to resolve this route to get target peers, and we need to deliver a particle to the target peer. In the terms of Aqua, it means that we want to state that we want to execute on target peer, and we expect that we want to get there via target relay. And then it means that if target relay is publicly accessible, then we can execute the code on the target peer. And finally, we have the problem of local routing that happens inside the peer. And in terms of Aqua, it means that we need to resolve some service that we care about, provide the local service ID for this peer. And finally, call a function. We assume that you know what function you want to call and you express it in types. So the last step is solved by the type system. Given this life cycle, we can understand what exact data is needed to provide routing capabilities. First of all, it's clear that we need to resolve a service, and how can it be done? How can we resolve a service? We might take some service ID and assume that it's given, it's part of the data provided by the routing algorithm. But for some algorithms or protocols, it might be not the case, because you might have a predefined alias, the name of the service, which is a very frequent use case for the JavaScript code in the browser. Usually you just register some service with a known ID, and it's predefined, you don't need service ID. Or you can run some local selection process to find the service inside the node when you got to the node. It could be any, but it's also the case. So it would be nice to have an optional service ID. And for the remote part, for non-publicly accessible peers, we need to have relay ID, a publicly accessible peer that we want to deliver the message before it's delivered to the target peer ID. And for sure, we need to have peer ID. So that's two fields that we need. And that's how it could be expressed in some kind of a pseudocode. We finally want to have the distributed routing in form of something like this. We want to resolve route ID into a collection of data structures with optional relay ID, peer ID, optional service ID. And actually, it's super useful to have an optional value to filter peers, or to have a vector clock in this value, or to have some nonce. So it's also super handy. And if we have such function, then we can have a Kademlia. We can have this function deployed locally. We can have a service with this function, and then we can use lookup from Kademlia to, it should be inversed. We can use neighborhood to decide on what peers to redistribute this data, and we can use the lookup to resolve addresses of relay ID or peer ID, and to deliver the message to have connectivity. And finally, it will be proportional to logarithm of the size of the network, if not cached. We can provide some cache for this request as well. So essentially, this is what we have in the service. Slightly more complex, but this is the meaning. Finally, we need to think about the route ID and to demystify it, how to register it, how to register to it. As we have an open permissionless network, we need the route ID to be a random hash to avoid collisions and to ensure immutability of the route's metadata. And the question is what exact metadata we want to have, and what exactly we want to protect from changes. Registry provides one default solution. It's not the only possible, but with registry, every peer can have an isolated namespace in this form. So the route ID is the hash that depends on the root owner ID and the label. Label is an arbitrary string, so you can build the route ID if you know target peer ID, and the value of the label. For example, you can say that the label for your Fluence-based protocol is, I don't know, user data. And then if you know peer ID, you can try to resolve these peer IDs, user data or user profile, for example, by hashing these two fields, his peer ID and the string user data, to get the root ID, to derive it from the data you know. And one important outcome for all this system is that there is no way to pick root ID of your choice. You cannot create the root ID like, I don't know, that's called my app, because it will be hashed. Just like you cannot upload different files to the same CID in IPFS or have two different names on IPNS. That's just the same mechanics. So finally, this are the data types that we actually have in the registry implementation. There are two structures. The first one is root. Here we have the root ID that is returned by the service or by the protocol to you, is derived from the label and the peer ID. Then we store timestamp created. Why do we store timestamp created, and why it's not the part of the root ID? Because you can. It's a very, very simple way to be able to update the metadata for the root. And the metadata is challenge. And finally, you have a signature that proves that all these fields were set by this peer ID. And then we have the record that references to root ID that could have some small value. It's points on the peer ID. It's set by another peer ID. You have relay ID, service ID, timestamp created, solution, and the signature. Signature secures all the fields above. And the last question is, what about the registry security? So first of all, both route and record are signed. So you cannot mutate any other peer's record, or you cannot register it for another user's behalf. So it's part of security, and this hashing mechanism is also part of it. And then, as you probably noticed, the root data structure contains an optional challenge and challenge type. And every record to be added, to be registered for this root must contain a solution. So you can protect, you can have some security checking for authorization for writes into your root for registrations. And we have the default implementation for challenges and solutions. It's called Trust Graph, and actually it's available now. There's no announcement yet, but it's published, and probably we will have another dedicated community call to discuss Trust Graph. And as we have a lot of working with the signatures here, there is a SIG service which is used to manage client signatures and key pairs. And it is also available. I'm not sure if we have the announcement, probably we should have it today or tomorrow, but the code is live, it's used. So we'll cover it also in a different call. I forgot to write down the use cases, but you can imagine the gossips, the chat rooms, mutual discovery, discoverable user data, or many devices for single peer without sharing the key pairs and so on. And now let's switch to the demo time. If there are any questions about the theory, it's a good time to ask. If not, let's switch to the demo. Demo.
Hey, demo.
Are the trust services live on Fluence nodes?
Sorry, can you repeat?
Yeah, I have asked that. Is the trust graph is live on Fluence nodes? Is it live?
Are you asking if it's live, or?
Yeah, the trust graph and sys service.
SIG service is delivered with the Fluence.js, and it's available. We just need to merge documentation, but actually you can learn how to use it from the demo code that I will present, or from the trust graph code that is available. But we will describe and have a dedicated announcement for SIG service. Trust graph is available. There is a JavaScript demo for trust graph, but we haven't shown it because these are two sides of one metal, trust graph and registry.
Yeah,
and
yeah,
we decided
I
to
can
show registry first because this routing problem is more useful, while trust graph is actually a very rich concept and very fundamental for the network security in general. But without registry, it's just some signatures, and there's nothing to show. That's why we decided to postpone the demo of trust graph and to show registry first. Registry was deployed on Krasnodar network today, so it's live right now. It might be slightly not stable. Maybe we will be fixing some minor bugs in the following days, but it's live.
Yeah, okay. I thought it was available, so it was live. Yeah, okay, thank you.
So let's switch to the demo. I hope it will work. So what I want to present, I have created a Fluence peer. I want to write down my name. My name is my name. And now I will register the route. And here, if you open this link with your phone or anything like that, that if you scan this QR code, then probably you'll discover that I exist. Oh, and here we have someone else. And if anyone else joins here, he will discover both of us, and will appear here. Yeah. So hopefully it works. It created 3 routes right now. For every device, there is a registered record for the relay and for this device, and they can learn about each other by asking me, and they find the way to me with the route ID. That's basically it. We have more and more people here. That's nice. You can take a look on the code in the registry demo repository in the Fluence Labs. And that's all I have. Thank you.
All right, thank you, Dmitry. Questions, anybody? Was he super exciting?
So one thing that I want to mention, we have this notation for discovery of the route, and if you think about it, it's super powerful, and this layer can be used for many purposes, including quite complex scenarios like gossip or data synchronization, managing replica sets, and so on. So hope we will be showing more different demos, which will finally have roots just in these data types, which are super rich. Any questions? Any reaction? If there's none, let's go. Woohoo! Here's the link to the demo in the chat. So if you want, you can take a look on it. Thank you.
Thank you. Okay. Nobody has any questions. I think that pretty much concludes. Does anybody else want to add anything? Anything you've been working on you want to share or particularly excited about? Really? That's no share environment here. It's anything but collaborative. Okay, well, in that case, thanks everybody. So Dmitry, when are you expecting to demo the trust graph? In 2 weeks?
Well, it should be absolutely possible. So we aim at having the demo in 2 weeks.
Okay.
And probably we will have it connected to the registry at this moment.
All right. So, and anybody who wants to use it, reach out in Telegram, Discord, any channel you want, and we'll be happy to support you in it. And I expect it to start popping up in upcoming hackathons as well. So getting a head start on it for those of you on the call, definitely is going to help you. All right. Well, see you in 2 weeks. Thanks, everybody.
Thank you. Bye.
Thank you. Bye.
Thank you.